Today on Supernova, we track down the echoes of the Big Bang. We wax poetic about deep sky observing. And we take flight through the Milky Way. Welcome to Supernova. I'm Eric Dunn. Over the past decade, cosmologists have made some amazing and unexpected discoveries about the universe. Among these great breakthroughs is the precise measurement of the heat radiation left over from the Big Bang. This is the cosmic microwave background, and it's given us an accurate value for the mass and energy balance of the whole universe. We now know that less than 5% of the universe is made up of atoms, the building blocks of stars and planets and people. 23% is dark matter, and about 72% is dark energy. And although we've detected dark matter by its gravity and dark energy by its effect on the expansion of the universe, we still can't explain what they are. Levon Pogosian studies the origin, composition, and evolution of the universe as a whole. Using data from the cosmic microwave background, or CMB, Levon writes equations and generates computer models to predict and replicate the universe as observed by astronomers. So how can astronomy help us in learning about the origin of the universe and its contents?
The way we learn about the past of our universe is by looking deep into space. The deeper you look, the younger objects you see. At some point, the universe is so young that galaxies haven't had time to form. So when you look sufficiently deep into space, at some point you stop seeing galaxies, you just see concentrations of gas. When you look even deeper, you even stop seeing gas because nothing is emitting light. And then if you look actually even further, you see a wall. That's a moment in which the universe transitioned from transparent to opaque. The universe at some point becomes so dense that you cannot see through. And that precisely is the image of the cosmic microwave background that's so valuable to us as a source of information about the universe. The CMB map is the best picture of the universe we have to date. It's essentially a photograph. It's a snapshot of the universe when it was 400,000 years old. The map is a picture of regions in space that were slightly denser or slightly more dilute than others. The redder spots are the slightly hotter regions, and the blue spots are the slightly colder regions. And the colder regions correspond to denser parts of the universe that are more likely to form stars and galaxies later on. If we treat the picture that we get from CMB as our initial state of the universe and try to put it in a computer and predict the universe as it looks today, based on that initial picture, it would not quite work without dark matter. But it turns out if you make dark matter approximately 22% of the total energy of the universe, then it works and it agrees remarkably well. One way in which you can learn about dark matter or observe dark matter is through its lensing effect. This is an image taken by the Hubble telescope, and it shows several galaxy images that are distorted by a huge lens, which is the cluster of galaxies that's in between us and those background galaxies. So the background galaxies, in the absence of the lens, would appear as point objects or maybe some spherical or round objects on the sky. But because of a huge cluster that appears to be in between us and those galaxies, the images are distorted into these arcs that you see on the picture. Most of the mass inside the cluster is invisible. You see only a small fraction of galaxies that are in the cluster. Most of the mass is in the form of dark matter. Yet dark matter still acts as a lens and causes that distortion. It's a really good time to be a cosmologist because on one hand we have a highly accurate data coming from satellites like WMAP, and based on that observations we've built a model of our universe that agrees very well with everything we observe. So on one hand we have these successes in explaining our universe. On the other hand, it still contains some really interesting puzzles. What's very exciting is that in the next 5 to 10 years, we'll have new kinds of instruments, new telescopes, that will have a huge potential for new discoveries. An explanation of dark matter or a discovery of dark matter and dark energy can happen any time.
Not only does our galaxy contain hundreds of billions of stars, but countless nebulae and clusters that are favored viewing targets for astronomers. Together with the galaxies beyond our Milky Way, these are called deep sky objects. To observe deep sky objects, you need a large aperture telescope, an observing site completely free of artificial lighting, and plenty of patience. But patience is what Lee Johnson has. Lee uses his 17.5-inch Newtonian reflector to hunt for distant galaxies that are out of reach to observers with smaller telescopes. And although these distant galaxies are seen as smudges in the sky, anybody who has observed them through an eyepiece knows how exciting they are to find.
When observing the skies, I like to think about where the plane of the Milky Way is in relation to the night sky at that particular moment. I like to think about where the north and south galactic poles are, because if you know where the Milky Way is in the night sky, you have a pretty good idea of where the open clusters and the planetary nebulas and so on are. They'll be in the disk of the Milky Way. And 90 degrees away from that, in either direction, you will find the galaxies. And there are two different kinds of distances among the distant galaxies. There's the local groups of galaxies, like the Andromeda Galaxy, or the M33 Pinwheel Galaxy, or M101 by the handle of the Big Dipper, including the Virgo supercluster, which takes us out to about 60 million light years. And we can often see detail in these local groups of galaxies. We can see their dust lanes. But when we are looking at the island universes that are 200, 300 million light years away or more, we do not see structure in them. They are so far away. We simply are happy if we can locate them. People talk about observing the Perseus A galaxy clusters near Algol in the constellation of Perseus. There are roughly 36 galaxies within a very small portion of sky, and they're faint little puffs of light. And you can see several galaxies at once. It's as if the background sky breaks out into a rash of little glowing seeds of light. Well, I've seen galaxies, in fact, as distant as 1.5 billion light years away. There's an Abell cluster in Corona Borealis, and I've seen several elements of that cluster. And I'm looking at light when I see those faint little galaxies. I'm looking at light that's about 1/3 the age of our Earth. And when you think about that, it's mind-expanding. The chains of distant galaxies we look at inspires such a thought of the gigantic awesomeness of the universe. It's a way of exciting our imaginations, as well as our scientific curiosity. The poet and the scientist come together in deep sky observing of this home which is our universe.
Aquila is the last of the summer stars to take the stage. This great eagle flies through the densest part of our galaxy, revealing the many riches of the Milky Way. Hiding from the eagle's fierce talons is the wild duck. A pale white blemish in binoculars, the smallest scope reveals tiny dancing stars set in a little box. It's an open star cluster, also called M11. An old-time observer, Admiral Smythe, said a dark lane running through the cluster looked like a duck in flight. Perhaps. Altair is the eagle's only first magnitude star. It can be recognized by two fainter stars that sit on each side. The trio are sometimes called the Belt of Summer, in imitation of Orion's belt in winter. Altair's brilliant white is a wonderful contrast to Gamma's pumpkin-colored orange. Altair is sometimes said to be the eagle that Zeus changed into when he kidnapped Ganymede. The unfortunate shepherd ended up waiting table forever without tips on Mount Olympus.
All astronomers are anxious to learn about the evolution of the early universe, and we wait patiently for the cosmologists to make the key discoveries that will explain dark matter and dark energy. But you don't have to wait for these discoveries to enjoy spending your nights hunting for distant galaxies. You might want to bring along a comfy chair and perhaps a computerized telescope. Thank you for watching SUPERnova. I'm Eric Dunn, wishing you clear skies.